Cubic foot is just a little block that much on a side, weighs about 175 pounds, which is to say you and I can't pick it up. You know, and that would be one of the smaller stones in the project. Almost all the stones in those buildings are at least that big or bigger.
So, how on earth did the Inca move rocks of 15 to 20 tons from the quarry to the site?
The logistics of creating Inca architecture were enormous.
For Professor Susan Niles, the Incas' greatest challenge is their lack of sophisticated equipment, like cranes or carts.
This is not a culture with wheels, with draft animals, with the kinds of machines that we take for granted. This is using human labor to move things.
This drawing, penned in the 17th century, illustrates how the Inca might have pulled it off. The Inca weave plant and animal fibers into thicker strands, then twist the strands into great lengths of strong rope. Using these ropes, Pachacuti's work crews were able to drag huge stones into place. But even a level surface would have presented a problem with this method. The friction created beneath the rock is enormous, and the leading edge of rock constantly scoops up dirt, creating even more resistance. Pachacuti's stonemasons must find a way to overcome this. First, to lighten the load, they rough shape the granite in the quarry, chipping off excess with hammerstones. At Machu Picchu's quarry, you can still see where stonemasons literally left their mark.
You can see that all around this section of the rock, they've been cutting with the hammerstones. They were cutting this so that this end of the block would eventually fall off, and then they would start to work it into a shape that they could use for building.
Once they have their mammoth stone roughed out, they employ yet another shrewd trick to help them move it.
It was very clever. They would take the bottom of the stone and smooth it off, and they would chip off all the edges all the way around so that it ended up slightly convex, like the bottom of a boat or a barge. And that way, they could not only drag it easily without the edges digging in, and they could turn it quite easily.
Finally, the workers might also cover the ground with small stones or gravel, which act like ball bearings so that the huge rocks can roll along. This huge slab of granite at Machu Picchu, abandoned by Inca workmen, gives us a snapshot of the work in progress. These techniques work well for smaller stones, but as evidence from Egypt and the statues of Easter Island suggests, moving larger stones requires the use of other techniques.
Most people think rollers were used routinely to move big stones in antiquity. Rollers are very hard to use in the field. They're impossible to use going uphill and downhill. The problem is you have too little friction. You can't control the stone. You're fighting the stone's tendency to roll around all the time.
And in the tight workspace on the mountain ridge, this could prove fatal. Building on the ridge is like working on the proverbial knife's edge. There's not enough space to have dozens of men pulling ropes, especially when placing stones on the lip of the cliff. This forces the Inca crew to find ways to reduce the number of workers needed to move big stones up and down slopes.
What you really want is what we call sleepers, which is like rollers, but they're fixed. They can't roll. And across that, you can move a sled quite easily.
Vince Lee believes he knows how the Inca moved the stones around the site. He believes they used ladders as sleds.
Lie this ladder on the ground. The only difference between this ladder and the one in your garage is that the rungs stick out beyond the uprights on the sides. You lay this on the ground, then you take a second one, put it on top of the first one, and you put your stone on top of the second ladder. Now with levers, you can apply force between the outriggers of the slide, the sliding sled that's carrying the stone, and the ladder that's stuck to the ground by gravity. The Egyptians did this routinely, and I think the Incas did too in close quarters.
This technique allows the Inca to move stones over the steep, rough terrain.
And it also means that you don't have a fancy road, you just have two ladders. You just keep leapfrogging one ladder in front of the other, and you can go all over the countryside.
Using clever techniques, the Inca found ways of moving stones across the difficult site. But the job will depend on manpower. Recruiting such an enormous workforce might seem a daunting prospect. But for the Inca emperor, this challenge is easily met, and it's met through taxation. Inca's subjects can pay off the taxes they owe to the empire by providing physical labor. In short order, overseers assemble huge work crews, and these citizen workers have vast advantages over slave labor.
You know, you can make slaves go to work, but you can't make them do a good job. All you can make them do is look busy all day long. And the workers that did this Inca stuff took the time to do it right. And we think that's probably because they had some stake in the results. They were proud of what they were doing as opposed to simply being forced to do it by overlords.
Despite the care they have taken, the Inca builders are about to discover that it doesn't take much to undo weeks of work. In this land of heavy rains and unstable slopes, one tiny mistake can bring the whole thing sliding down around their ears. Perched atop a precarious mountain ridge, Machu Picchu's engineers are engaged in a constant battle with gravity. The terraces they have so carefully constructed sculpt the mountainside, supporting the city and anchoring it to the landscape. But in the lower terraces, a disruption in the pattern. Something has knocked the terrace walls out of alignment. Others have disappeared under an earthen blanket. Up higher, the steep slope has shaken off the soil that once cloaked it. This was a landslide. The earth has given way along a natural fault line, damaging the terraces. Believed to be a slow but destructive event, it stretches 140 meters down the hillside. But Pachacuti's work crews adapt as always, assess the cause, implement a plan, and repair the damage. Their solution is familiar to modern-day engineers, but 500 years ago, it's revolutionary. Pachacuti's men cut a drainage channel above the disrupted terraces to redirect surface water and prevent further damage. They can't afford to take any chances. If the heavy rains of the region soak into the foundations, the waterlogged substructure could ooze away with catastrophic results. So, building by building, wall by wall, the engineers punctuate the site with drainage outlets and downspouts. 130 in all. In heavy rains, these channels divert water into a large storm sewer that safely empties into the rainforest below.
One thing you never will see in Machu Picchu is a pool of water standing on the surface. Yeah, and as much as it rains, and sometimes it rains really hard here, that's always draining away. You never see it.
Once the land is cleared and these firm foundations are laid out, Pachacuti stonemasons can build the homes, plazas, and temples that will make up the site. As always, they work with nature, sculpting it, so that here, the buildings flow gracefully across the mountaintop.
Most cultures sort of cut the top off. We certainly do, for example, in our culture, just cut the top off and put a building on top. But somehow the Incas managed to celebrate the natural contour of the land and the natural amenities of the land and enhance them with their structures rather than work contrary to them. Very unusual and beautifully done.
Temples for worship, houses for living, bathing areas, and a grand plaza for gatherings and games. Only the rock walls remain. Thatched roofs once sat on these structures and shed the heavy rains. But that's not all they had to withstand.
In this part of the world, you can get very strong winds sometimes in the Andes, and air flows over the top of the roof like air flowing over the top of a wing of an aircraft, and it gives lift underneath, and it can just lift the roof straight off.
So the roofs need to be lashed firmly to the structure. But how? The Inca have strong rope, but little else. As always, they find their solution in stone.
If you look at the end of the building here, you can see all these stone pegs. Then if you follow the line of the gable end, you can see these ring stones set into the gable end. This was part of the system for securing the roof beams and the roof materials.
The roof pegs were built and assembled right on site for each of the 170 structures that make up the urban section of Machu Picchu. But the truly remarkable craftsmanship is in these features. Windows and doors framed out of rock. These distinctive trapezoidal shapes of the rocks and door and window frames take us back to the height of Inca cultural power. Each one is carved and placed by highly skilled stone masons. The masons join the stones without using cement or mortar. Yet the seams are so tight, they dazzle modern-day architects.
You often hear people say, oh, you can't get a knife blade in the joint. You can't get anything in the joint in some of these places. The stone just simply changes color a little as it goes across the joint. It is miraculous.
How Pachacuti's craftsmen could achieve such quality without iron tools seems like an impossible challenge. Yet the stones they crafted fit together precisely. Researchers have found vital clues to the Inca technique in these large granite chunks left unfinished at Machu Picchu. Smooth pockmarks in their surface indicate the use of smaller stones, called hammerstones, to shape the rock. Inca stoneworkers pound the surface of the granite with these rounded stones obtained from riverbeds until they have a smooth surface covered in dust. As the next stone is laid, the stonemason uses imprints in the dust as a guide to areas needing further work. Using progressively smaller hammer stones, the masons get a closer and closer fit until the facing top and bottom surfaces are a perfect match. This method creates a unique feature of Inca architecture.
You will never find a straight line or a right angle corner in an Inca building unless it's done by accident. You will never find that. You will see sites which superficially appear to be sort of squared off stones, but if you study them carefully, they aren't square at all. They're just slightly off square. And this is very, very difficult to do. As long ago as the ancient Egyptians, people discovered that the easy way to put two big stones together was to flatten off the sides and then put the two flat sides together. You'll never see that in an Inca building.
How did the Inca manage to get these irregular shaped stones to match up so perfectly? Once again, the stones themselves provide the clues. These walls have settled slightly and pulled the stones apart.
What they've done here is they've made a perfect join between each stone all the way to the back, the whole depth of the stone. And not only that, but it's one face is concave and the other is convex. So they're perfectly fitted together in a very difficult way to accomplish.
The same perfect fit can be found all over the site, both in smaller stones and in mammoth ones. They appear to have been created by the same method of fitting, removing and refitting regardless of size.
So the question is, how did they achieve that fit?
Vince Lee thinks he may have the answer. It's called scribing, a technique sometimes used by log cabin builders to fit irregular